Can you guys hear me? Okay, good. So where were we last time? What had we studied in the last class? Scope. Okay, so scope, if you remember, we had discussed that scope, you can view it in two dimensions. One is the lifetime of a variable. When does a variable comes into being, and for how long does it exist? And the other dimension in which you can view the scope is accessibility or visibility. Okay? Accessibility or visibility, as it is called in your book, is the notion that in which portion of your program that variable is visible, or in other words, from which parts of your program you can access that variable, you can use that variable. Okay, so that is the accessibility or visibility of the variables, scope, the dimension of the scope in terms of accessibility or visibility. So we had studied the scope, both dimensions of the scope for global variables, both dimensions of the scope for local variables, and both dimensions of the scope for static variables. Okay. So if anybody has any questions regarding that, you can ask now. What, no questions? Everything is clear to everybody in terms of scope, static variables, global variables, local variables? Okay, if you guys are not going to speak, then as I said, I'll assume answer of my choice, which is that everything is good. So the other day we discussed the scope resolution operator. Okay, so I verified later that what Mohammed Fareh said was correct. The scope resolution operator is used to access global variables. Okay, if there are two variables of the same name defined in two enclosing scopes, one scope is enclosed in another scope, then when you access that variable by that name, the variable defined in the inner scope overshadows the variable defined in the outer scope. Okay, which means if x was defined in two scopes, the outer scope and the inner scope, and in the inner scope you access x, then the inner x or the x defined in the inner scope will take priority. Okay, so x, you will be referring to x defined in the inner scope. The x defined in the inner scope overshadows the x defined in the outer scope. Okay, so if one of them is a global variable and the other is a local variable, then you can use the scope resolution operator to cancel this overshadowing and access the variable defined in the outer scope, which is the global scope. Okay, so scope resolution operator is used to access, in such cases, variables defined globally. Okay, so you guys should correct or cancel what I had said earlier. Any questions? No? Okay, if that is what you wish, then how to access variables out of scope other than global scope? By out of scope, you mean variables defined in the outer scope, right? Because out of scope means that the variable is not inside any scope, in the scope that you are in. So outer scope variables are not accessible, but if you want to access the variable defined in the outer scope, then I'm afraid there is no easy way. Yes, you are right. So that's the variable defined in the outer scope. I'm afraid there is no easy way to do such a thing. Okay, there are workarounds. If you search on internet, there are workarounds, but normally you should, avoid such workarounds. Okay, because you should try to do things that are specified by the standard in the ways that are specified by the standard. If the standard does not specify something and you have to find a workaround to do something that you're trying to do, then maybe there's a flaw in your design. Okay, so you might want to change your design to do things in a way that is according to the standard. Okay, so if you want to, if you have to find workarounds to do things in a twisted way, then maybe you're doing something wrong. So in this particular case, if I had three variables named x defined in three different scopes, and those scopes are enclosed in each other, which was the global scope, then was the scope of the main, and then scope of the for loop, then it is, I think you can perhaps see that it is a design error on my part to define or name variables which are enclosed in such a way and give them a same name. In this case, for example, I could have changed my design or reworked my problem to name them differently. For example, I could have named the global x variable as global x, the variable in main as main x, or the variable in for loop as x3 or whatever. Okay, so if the names are different, then they will not overshadow each other. And variable renaming is something which is in our control. Okay, if something is in our control and that makes the life easy for us and would make us do things in a standard compliant way instead of finding a twisted workaround, then we should change our design to make our life easier. Is it clear? Because variable renaming is always in our control, and it is always better to follow standard practices. Okay, standard practices means whatever things are dictated by standard, they are like the conventional ways in which the designers of the language had intended the things to be. It is good to follow their guidelines or their specifications. But however, if you are like stuck somewhere in a situation where there is nothing in your control and things are designed in such a way that you have to go within the loopholes in the standard to find some workaround, in that case perhaps it's justified, but normally at your level you should try to be as much standard compliant as possible. That will first of all make your code clean, easy to understand, and there will be less chance of being buggy or having an error in your code. Okay, so there was a comment that scope is basically a region where a variable is accessible. Yes, accessibility wise, but also there's the lifetime dimension of a scope. For example, a static variable which has been defined inside a function, it is not accessible from outside the function. Okay, but the variable still lives on until the end of the program. Yes, Uzair, you want to say something?
सर मुझे स्क्रीन नजर नहीं आ रही.
Because I have not shared any screen yet. I was just, before starting the class, I was seeing
Okay,
if
sir.
you guys had any questions.
Okay, sir.
Okay, so any other questions? So static variables, I hope static variables concept is clear, that it is created when the function is called, the static variable defined in a function is created when that function is called the first time. Okay, and it lives on even after the function is finished. And every other time that function is called, the variable creation step is skipped. Otherwise, all the function is executed. Okay, variable is created only once the first time the function is called. Okay. Any other question? No? Okay. So if there is no more questions, then let us. Sir, when the static variable is destroyed? Static variable is destroyed when your program ends. Okay. After the program is finished, everything associated with that program is destroyed, which includes all the global variables as well as the local static variables. Okay. Okay. So if you are good with all this, then let me share my screen with you guys. And let us see. New full screen. So I hope you guys can see the terminal, and let us open the. Now, let us continue our discussion related to the scope of variables, and let us do something interesting. This is okay. Is this code clear to everybody? What is happening in this code? Yes. Okay. So, okay, I'll slightly modify it just to make it good. Instead of doing this, we'll do this. Basically, it's the same, but to illustrate my point, I am just doing it more in more number of steps, so that it is easier to understand the thing that I'm going to communicate. So just to verify that you got it right, we will just compile and run it. Okay, F1 returned 56. So F1 returned 56. So F1 is called, F1 var is created and initialized to the value 56, and then F1 var is returned. Okay? F1 var is returned, and on line number 11 here we receive the return value of F1. Okay? and then that value is assigned to x. Now, on line number 11, to the right of the assignment operator, what replaces f1, the call to f1? Is it the variable f1 var or not? What replaces the call to f1 on the right side of the assignment operator on line 11? Yes, f1, what does that mean? Very good. So it is not the f1 var, it is the value of the f1 var that replaces the call to f1. Okay. What's the difference between f1 var and the value of f1 var? Does f1 var exist after the call to f1 has returned? No. When f1 has returned, f1 var, which was created when f1 was called, has been destroyed because f1 has finished execution and f1 has returned. Okay. So f1 var, since it has been destroyed, it does not replace the call to f1. However, since f1 function is returning the variable f1 var, so return statement basically copies the value it has and returns the copied value. Okay. So basically the value of f1 var is copied and replaces the call to f1 on line number 11 on the right side of the assignment operator. Okay, is this thing clear? That f1 var does not exist after the call to f1, so it cannot replace or it cannot exist at the right side of the assignment operator. It is the value of the f1 var variable which is copied and returned by the function, and that value basically replaces the call to f1. Is anybody confused about this thing? No, it's clear to everybody? Saleh, you're confused or is it clear to you?
Sir, confused about it a little bit.
No, but do you understand the concept that the f1 var, the variable, which is local
Yeah.
to the function f1,
Yes,
it will
sir.
exist only within the scope of the f1 function.
Yes, sir.
It is created whenever the function f1 is called, it is created. It will exist during the execution of f1 function,
Yes,
and
sir.
when we reach the closing curly bracket of the f1 function, all its local variables are destroyed, including f1 var.
Okay, sir.
Okay. However, since before the curly bracket, f1 var is returning, sorry, f1 function is returning the variable f1 var. So what the return statement will do, it will basically copy the value of this variable. So basically return statement, it can have an expression. Okay. So whatever expression is here, return statement will evaluate that expression and copy the result of the evaluation of this expression and replace it here. Okay. So here the f1 var, the expression is only a variable. So evaluating a variable basically gives us the value of that variable. So return will evaluate f1 var and it will basically return the value of f1 var. Okay. So it will copy the value which is stored in the memory location of f1 var and replace that copy of that value here. Okay. The variable f1 var with its memory location associated with it. It existed only during the execution of function f1, and after f1 is finished, that variable along with its memory location has been destroyed. Okay, but before the destruction, we copied, or the return statement copied, the value of that variable and replaced it here. Is it any better now? Saleh and Khushal? Okay, they both are now responding, so we'll move forward. Does return statement store in memory if not assigned to any variable? What does this mean? Mohammad Ahmed, what do you want to say?
सर रिटर्न स्टेटमेंट कहीं स्टोर होती है जब मतलब वो हम किसी भी उसकी वैल्यू यूज कर रहे होते हैं?
No, statements. Sorry, go ahead.
सर या सिर्फ वो कॉपी करके जैसे सी आउट होता है डिस्प्ले करवा देता है, कहीं स्टोर नहीं हो रहा होता?
No, cout basically copies whatever you give it to the screen. Okay. Return statement also copies the value. Return statement copies the value, but where does it copy? What is the destination where it copies the value? Take a guess.
सर मतलब ये f1 var जो है इसने 56 वैल्यू जो है रिटर्न में ली है ना, तो
Yes.
f1 जो फंक्शन है उसने f1 var की वैल्यू कॉपी की है, तो वो
No, the return statement, it will copy the value of the variable f1 var to the location where that function was called. Okay, so the destination, it will copy the value to wherever that function was called. Okay, as Umar Farah and Usman said, it will copy to the main line number 11 where that function was called. Is it any clear? Okay, good. Okay, so this thing, if this thing is clear, then let us do something interesting. Why is it not working? Yes. So instead of a single variable, let us return an array from a function. Okay, so this is an arrays, just as we passed arrays as pointers. Let us try to return an array also as a pointer. And here, instead of since f1 is returning a pointer on the right side, and as we know, on the assignment operator should have same type of things on both sides, on the left hand side as well as on the right hand side. So since on the right hand side f1 will return a pointer, on the left hand side also we receive that value in a pointer. Okay. And here we would, since it's an array, we can't print an array directly, so what we will do is we will like put a loop here. I++. And I hope you guys remember that we can access the array with the pointer of the first pointer to the first element, it should be I, and we can basically okay, so we are returning the array from F1, and since the name of the array is a pointer, so the return type of the name of the array is a pointer to the first element. Okay, so A is a pointer of type int. So the return type of F1 is a pointer of type int. So whatever it returns, we will receive it here. And again, we receive that value and store it in a pointer of type int. And since we expect this pointer is pointing to an array, so we can access this array by using this pointer like this. Okay, is it clear? What this program is doing? Is it understandable? Why do we use loop? Because we want to display the elements of the array, and we can't display the elements of the array directly. If you remember, before mid we studied arrays, and we had said that if you want to do an operation on an array, you have to do that operation on every element of the array. Okay, or cout x plus I, exactly. So it's the same thing. Okay, so that's why we need a loop if you want to display an array, because we have to display each element of an of the array individually. Okay. So line number 14, what is it about line number 14? Yes, so it is basically displaying the elements of the array one by one, and it is exactly the same thing as you guys mentioned. This is equal to x plus I. Okay, so x contains the address of the first element of the array. So is it clear to everybody? Okay, no response, so I hope it's good. So let us see some interesting things when we run this program. Here we go. First of all, the compiler is saying something to you. Okay. The compiler is giving you a warning. Okay, always listen to your compiler. Your compiler is your best friend in programming. Warning is, you should never ignore the warning of a compiler. And also read the error message, warning messages, and you will know what is the problem. Okay, if you start understanding these messages, half of your problems are already solved. So the warning is line number 5, column 7, warning, address of local variable A returned. Okay, so here it's a local variable A whose address is being returned by the program. So let us see it's a local variable A and its address is being returned by our program. Okay, is it clear what the compiler is saying? What? No, the compiler is saying that you are returning the address of the local variable. So what are we returning in this function? Mohammad Aman Uzair, what are we returning in this function? I mean, the code is written, can't get it, but why address of the array's first element? Very good. Okay, so we are as you guys know, for the others who are saying they can't get it or they don't understand, the name of the array is pointer to the first element of the array. Okay, so the name of the array is basically the address of the first element of the array. Okay, so we are returning a, which is the name of the array. So we are returning the address of the first element of the array. Is it clear so far? Uzair, to you? Okay, Usmantar, it will not be ampersand a because a itself is a pointer which contains the address of the first element of the array. Okay, so we won't return ampersand a, but we will return a. Okay, good. So, okay, so now is it clear the warning of the compiler? It is saying we are returning the address
Yes,
of the local variable of the array, and since a and all its elements are local variables, and we are returning the address of the first element of the array, so we are returning the address of a local variable. Okay, so the compiler has warned us about this thing. Okay, so if the compiler has warned us about this, why is the compiler warning us about this? I think it's better if I write it here like this, as you guys have said. It will make things easier. Okay, this is exactly the same thing, but just to make things clear, I am writing it like this. So we are returning the address of the local variable, and then using that address, we are dereferencing that address to read the values of the array A. This array A, we are dereferencing these addresses to read the values of the array A. Is it clear to you guys? What are we doing in line number 14? Is it clear? Because this is a crucial point. No. We discussed that we are returning the address of the first element of the array from function f1. Is this point clear? What is being returned by the function f1? The function f1 is returning the address of the first element of the array, and since all elements of that array are local variables, so we are returning the address of a local variable, that is the address of the first element of the array in function f1. Function को pointer क्यों declare? Function is returning, the return type of function is pointer because we are returning an address from the function, and the return type of function is always indicating whatever we are returning from that function. And since we are returning an address is a pointer, so the return type of this function is a pointer, an integer pointer. Is it clear, Mohammed Ahmed? No, Usman Tahir, let me get to where I'm getting and then you can suggest new things. Okay. To you guys, Salha and Hamdan, is it clear? What function f1 is returning? Why is the return type of function f1 integer pointer? Okay, and Salih? Okay, good. So if F1 is returning the address of the first element of the array. We are storing that address returned by F1 in the variable X. Okay, so X now contains the address of the first variable of the first element of the array. And in line number 14, we are dereferencing that address. Remember X plus I. So X plus I, first it will be X plus 0, then X plus 1, and then X plus 2. Okay. So all those addresses, we are dereferencing them one by one. And what does dereferencing an address do? It returns us the value contained at the address which we are dereferencing. Okay. So we are basically accessing the values of each element of the array one by one on line number 14. And we are printing those values. Is it clear? Is the working of line number 14 clear to you guys? So we are printing the values, not that. It's very good. Yes, that's exactly we are doing, because we are dereferencing those addresses. And dereferencing an address returns us the value contained at that address. Okay. Okay. So if that is clear, then we are using those addresses to access the values of the elements of the array A, which was local variable to the function f1. Now look at the compiler warning. Compiler says we are returning the address of a local variable. And look at line number 14, what we are trying to do. Can something go wrong? X is the address of A in hex. When we add the integer values of I to addition base 16. Muhammad Farah, it doesn't matter which base you are in. A value written in any base, it might look different, but it's the same value. Okay, so therefore, when you do addition, for example, if you add 1 to a value in any base, its value will be incremented by 1. Okay, so it doesn't matter whether X is in hex or A is in hex. Is it clear? These bases, they are just for representations. Representations are visual. The value in the background is the same. For example, the value 15, decimal 15, written in decimal, it is 15. Written in hexadecimal, it is F. Written in binary, it is 4 ones. The appearance is different, but the value is the same. Usman Tahir, we are not trying to solve the problem. First, we have to illustrate the problem. We'll come to it solving later. So the problem, as Mohammed Ahmed rightly pointed out, the function f1 has finished. After function f1 has finished, we are using the address of the local variable returned by the function. Using that address, we are trying to access that local variable which was local to that function and which has now been destroyed. Okay, so we are trying to access a variable which has been destroyed. Yes, Mohammad Fareh, when we add 1 to that pointer, integer pointer, it will be actually incremented by 4. It will move to the next location. Okay, so that part of the code is right. But the problem is we are using the address of a variable which no longer exists. Okay, as Muhammad Ahmed said. Does everybody understand this? We will see what it gives. It compiles because it only gives an error. Oh, sorry, it only gives a warning, it does not give an error. Okay, so with warnings, the compilation succeeds. Okay, so it does succeed in compiling, but what will happen, we'll see. So Muhammad Fareh, what I was saying was that on line number 14, we are using the address, or we are dereferencing the address of a local variable for function. The address returned by F1 was of a local variable, and local variables, as we know, after the function is finished, local variables get destroyed. Local variables get destroyed. So on line number 14, we have the address of a variable that has been destroyed. We are dereferencing that address to get the value of a variable which no longer exists. Does that sound problematic to you? Is it clear, the problem? To all others? Yes, the variable has been destroyed, but we are using its address to get to its values. Okay, but since the variable has been destroyed, and we know that now that memory might be allocated to anything else, so that address is no longer valid. Okay. Yes, Mohammad Fareh, the array elements have been destroyed when we after the function call in main, because the array was a local variable. Okay. And since that variable has been destroyed, that memory might have been allocated to something else. So these addresses that we are using are no longer valid. Is it clear? To others? Okay, so if it is clear, then let us see what happens when we use such invalid addresses. So we compile it again. You see, same variable warning, we are returning the address of a local variable. Okay, and the compiler knows that this local variable will be destroyed when this function is finished. So if somebody is returning the address of a local variable, then most probably they don't know what they're doing. Okay, so that's why it gives you a warning. So if we run this program, you guys see what happened. Segmentation fault. This is something that normally you will see in, a lot if you program in C and C++. What do you guys think happened? Yes, very good. The program crashed. Very good. The program crashed because it was trying to access a memory which was no longer valid. Okay. So the operating system basically kills any programs that try to access memory which is not allotted to that program. Okay. Since the array has been destroyed, and using the array's address, we were trying to access a variable that has been destroyed and a memory which has been destroyed. So well, it's also called an out of memory access. So our program got killed by the operating system. Because the address is not destroyed, the memory which this address is pointing to, that memory has been destroyed, that variable has been destroyed. Okay, so we are trying to access a variable that has been destroyed. You know, function variables are local variables. They are allocated on stack and they live only for as long as the function executes. Once the function execution is finished, those variables are destroyed. And once those variables are destroyed, we have no right to access them. The variable address has not been destroyed. The variable itself has been destroyed. The memory location has been destroyed. Okay, so we can't access or we can't read value from a memory location that has been destroyed. Is it clear? Yes. Okay, good. So if this thing is clear, then our question is, how do we return an array from a function? If we return a normal variable, it's easy. The value of that variable is copied and copied by the return statement, and we get the value at wherever that function was called. Okay, so the value is copied. But the problem is arrays cannot be copied like this. To copy arrays, we have to copy them element by element. Okay, and return statement does not work on element by element basis. Return statement can return only one thing. Okay? So we tried returning the address of the array, but the problem is by the time we get access to that address and we try to use that address, that array has been destroyed. Okay, so how can we return an array from a function? No, we'll neither make it static variable nor we are going to make it global variables. For a for loop in function, return element by element. Okay, Mohammad Fareh, that would have been a very good suggestion, but the problem is in a function, a return statement can be executed only once. Wherever you execute the return statement, the function execution finishes and the function returns. Okay, so in a for loop, if you execute return statement, then the first time that return statement is executed, the for loop ends and the function returns. Okay, so return statement can be executed in a function only once. No, array int main, I don't know what you're talking about. Survey if you out see out array AI in F1. No, we are not trying to print the value of array in F1. We are trying to return an array from F1 so that we can use it in main. Okay, Uzair, the goal is not to print the values inside the function. The goal is to print the values outside the function. So we have to first find a way to return the array from the function or make an array in such a way that it can exist even after the execution of the function has finished, and then we can use that array in main. So one method can be, as Usman Tair said, to make it global, but we are not going to use global variables. Global variables are usually bad things. We should not use global variables. It is discouraged to you guys to avoid global variables at all costs unless it's a matter of life and death or something. Okay. So static is not a good solution for this neither. We'll see, we'll talk about it later, but also we are not going to make it static also. Yes, Ozair, you want to say something?
Sir, please show the code me for a while.
Okay, the screen is like this. Okay, there you go. Normally it should be visible now.
Sir, if we don't initialize this pointer x to the f1 in the same line, first of all, if we declare means int static x, and just end the line.
Okay.
Means if we put semicolon after that.
Okay.
Now, sir, x is equal to f1.
Huh.
Sir, if we try it now.
No, it's the same thing. It's the same thing because f1 will return the address of a, which we'll store in x, and we are going to use that address here. So by the time we start using that address, that array has been destroyed. Okay. We are dereferencing this address to access a memory location that has been destroyed. Okay, so the same problem exists.
Okay.
Okay, so the class time is ended. So I hope you found the problem interesting and think about it, and we'll continue this discussion in the next class. Tomorrow is our next class, right?
Sir.
Yes.
Walaikum assalam.
Somebody wanted to say something.
Yes, to me, sir.
Please go ahead.
सर वो जो आपने जो असाइनमेंट के लिए क्वेश्चंस दिए थे
जी.
उसमें क्वेश्चन नंबर 3 and 4 आर ऑलमोस्ट सेम. ये
Yes.
कोई एरर था कि नहीं?
Yes, that was a mistake on my part. Do them same.
जो सर वो जरा क्वेश्चन नंबर 2 जो था वो जरा समझा दें सर, समझ नहीं है मुझे.
I'm sorry, वो अलग से पूछें कांटेक्ट करके. This is the class time and we are going to discuss the class
Okay,
topics,
sir.
not the assignment topics. So tomorrow at 9 a.m. Yes, 9 a.m. we have our class, and we'll continue this discussion tomorrow at 9 a.m. Okay. Meanwhile, try to think about the problem. Try to understand the problem. What is the problem, and try to replicate this problem in your own code. And then tomorrow we'll see how we can solve this problem. Okay. So the concept is heap, something that which we have not studied until now. Okay. We have studied about stack, but we have not studied about the heap. Okay. So tomorrow we'll see what is a heap and how we can use the heap. Okay. Not DMA, heap. Okay. So the class tomorrow is at 9 a.m. Okay, not at 12 ke baad, because 9 a.m. was agreed by all of you at that time. Okay. So tomorrow 9 a.m. is the class. Yes,
Sir?
Uzair. Ji.
Sir, one last suggestion, please. Sir,
Please.
if we remove the steric from the steric x plus I.
Then we will only be printing the addresses. We are not interested in printing the addresses. We are interested in printing the values.
And after this, if we dereference the address of that variable.
So it will be the same thing. By dereferencing that address, we will be accessing a memory location that has been destroyed. The problem is not the dereference. The problem is that the memory location has been destroyed. The variable has been destroyed. We have to somehow find a way so that that variable can live even after the execution of the function. Okay. There are solutions, as some of you suggested. Global variables can live after the execution of the function, and static variables can continue to live after the execution of the function. But these are not the paths that we're going to take. Okay. Global variable and static variable are not the solution to this. There is another solution, which is using heap, and we'll study tomorrow what is heap and how we can use it. Okay, is it clear?
Okay, sir, thank you.
Okay, so we meet tomorrow at 9 a.m. and here you can mark your attendance. I'll stop the recording.